Welcome to the sixth and final week of the course. You've made it to the end and you're almost a real Hyperloop expert by now. In this wrap-up video, we'll briefly go through the topics of each week to refresh your memory. Afterwards, we will discuss the main challenges for the implementation of Hyperloop. With all of the knowledge gathered over this course, you are fully prepared for the final assignment, which will also be introduced in this video. At the start of this course, many of you didn't know what a Hyperloop was and why it could be the future of transportation. The first week, we discussed the basics of the Hyperloop. The two fundamentals are a vacuum tube and a levitating passenger carriage. The vacuum tube makes it possible to move forward with minimal air resistance, and the levitation guarantees a low friction between the pod and the track. These two features make it possible to move a Hyperloop pod at speeds of an airplane, but as efficient as a train. Moreover, it can float very smoothly over the track, dampening present vibrations, and this increases passenger comfort. Ideas similar to the Hyperloop have been around for hundreds of years. The concept became very popular when Elon Musk revealed the concept with the name Hyperloop in 2013. From that moment onwards, the development gained momentum and hundreds of project teams around the world are working on it. In the second week, we've looked into some technical subsystems of the pod. The levitation, propulsion and braking were highlighted. Levitation is a crucial feature of the Hyperloop and can be realized passively or actively. The latter requires systems with sensors to monitor the pod-track gap constantly in order to maintain the levitation. The propulsion has to accelerate the pod and maintain the cruising speed once that has been reached. This works based on electromagnetism. By calibrating the coils in the track or pod, a forward motion can be generated. The braking works the other way around. There are several configurations possible for the propulsion. We've asked ourselves questions such as, how fast do we want the pod to accelerate? Do we want batteries on board, making the pod heavier? Or do we want the pod to be passive? What is the configuration that results in the lowest energy consumption? Questions like these are very important in making a design choice for the propulsion. Then we discussed the pod, which is jargon for passenger carriage. For the design of the interior, we could learn a lot from other modes of transportation, such as trains or airplanes. However, there is a challenge. Since passengers will travel in a pod without windows in a vacuum tube, it could feel claustrophobic. Therefore, the focus of the interior should be based on passenger comfort, spacious seating layout, making use of light colors to create a sense of openness, screens that display the outside world and mimic the amount of sunlight outside. Moreover, safety is a priority to take into account when designing the interior. Besides that, we should always think what a design choice does with the weight of the pod. Since the pod levitates, every kilogram that it has to levitate costs a certain amount of energy. The heavier the pod, the less energy efficient. Therefore, materials such as aluminum and carbon fiber are considered for the outside of the pod. They have a high strength-to-weight ratio compared to other materials. Now we have thought about the pod itself, we can start designing the infrastructure through which the pods move. This was the main focus of week 4 and 5. The infrastructure will be completely new, and this means that the tube has to be constructed underground in highly populated areas. The tube shields the pod from the outside elements, such as rain and wind, and this reduces the amount of maintenance that has to be performed. Moreover, safety is a priority at all times. The pods move through a vacuum environment, which is dangerous for humans. What to do in an emergency situation? What if someone has a heart attack? Should we first operate with cargo before transporting human passengers? For these kind of questions, a regulatory framework is required. Regulation and standardization are important steps in the realization of the Hyperloop. It is important to think what cities to connect with a Hyperloop network. Since it is a completely new infrastructure, it will cost a lot of money, about 40 million euros per kilometer. Therefore, we have to find network links that could earn back that huge investment cost. In other words, where there's a high demand for high-speed transportation. The network could, for example, be determined on the basis of air traffic data. If there are a lot of flights between cities, then the expected demand for high-speed transport is high, and it could be potentially beneficial for a Hyperloop link. But who is going to pay for it? Is it the government or companies? And what if companies design their own Hyperloop pod? We have to make sure that there is a standard for pods and the infrastructure. As we have seen throughout the course, the Hyperloop is still far from implementation. Some of the biggest challenges are finding parties to finance the development and to pay for the infrastructure eventually, setting up new certification tailored to the Hyperloop, standardization of the pods, track and tubes. Moreover, in order for the Hyperloop to compete with short to medium haul air traffic, we need connections to be international, connecting cities in different countries. This brings along political issues, and every country has different regulations to take into account. In the final assignment, you're going to up with a plan to tackle one of the greatest challenges for Hyperloop implementation yourself. With this, you can contribute to the future of Hyperloop. As the Hyperloop course team, we would like to thank you for your participation. We have enjoyed your discussions on the discussion forum. We have admired the assignments you submitted and are grateful for your eagerness to learn more about the Hyperloop. We hope you have enjoyed the past 6 weeks, and we certainly did. Good luck with the final assignment.